Hello guys, so today we are here to solve a very interesting problem called single element in a sorted array. In this problem, we are given a sorted array of only integers and every element appears exactly twice. So the number of times any element appears is two times except for one element which appears only once. So we are given an array and in this array we are only having only integers. And every element appears exactly twice. Okay, and there is one element, you know, which should appear twice, but it's only appearing once. And we are given the task to find that single element, okay, that is appearing only once. And also the constraint of the problem is that our solution should run in log n space time and big of one space. So we should not be, uh, taking any extra space, and our solution should run in log n time. So it's asking us to, log n time can only be achieved when you are, eliminating the search space by half in each iteration. So if you are doing sequential search, it is going to take big O of n time. But if you want to do, mm, if you want to do log n time complexity, if you want to achieve log n time complexity, you ought to eliminate the search space by half in every iteration. So how to do this? Okay. So to do this, int low is equal to 0, high is equal to nums dot length -1, and then mid is equal to -1. So we have declared all the required variables here. Low is equal to 0, so low is pointing to the least index, high is pointing to the highest index, and mid is, as of now, it's not pointing anywhere. And we are going to, uh, declare the mid value in each iteration. So low is less than high. What is the meaning of low less than high? What is the meaning of low less than high? The meaning of low less than high is that, the while loop will only be running till the time low is less than high. As soon as low becomes equal to high, or or anywhere, it goes, at the equal to high or greater than high, we are going to terminate it. So as soon as it becomes equal, we are going to terminate the loop. So at the single point, we are going to terminate the loop. So the point where we are going to converge, we are going to terminate the loop. So with having said that, now let's, define the value of low. So low plus high, if nums of low is less than, if nums of low is not, nums of mid is not equal to nums of mid -1, and nums of mid plus 1 is not equal to nums of mid. Return nums of mids, since we are asked to return the number itself. So we have to, the single element that appears only once. So you have to return that. So we are checking mid is not equal to mid -1 and mid plus 1 is not equal to mid, then that element itself is mid. And we are returning that. Else if mid -1 is greater than equal to 0, mid -1 is greater than or equal to 0, then, and nums of mid is not equal to nums of mid -1, nums of mid is not equal to mid -1. So okay, so it could be this kind of situation. Mid is not equal to mid -1. Then we can, do a check. Okay, mid is not equal to mid -1. So if low minus, let's do mid minus low, low, and we declare this %2. Okay, mid minus low %2 is equal to 1. Okay, if mid minus low %2, if mid minus low %2, okay, um, is equal to 1. So I'm checking here, uh, the, suppose, mid is this point, this, third value point. So mid minus 1 is, this thing minus 0. So here we are having three elements. So if, three elements are there, or any odd number of elements are there, then what we are going to do, that we are going to, make high is equal to mid minus 1. So we are eliminating one subspace. Else what we are going to do, we are going to make low is equal to mid plus 2. Why we are doing mid plus 2? Because this and this element are the same. So if mid is at this first 3 point, we need to make mid not just here, we should cross and come to this fourth index value, so which is plus 2. Same way we need to do with if mid plus 1 is less than mid plus 1 is less than equal to mid plus 1 is less than equal to, we should say less than, not less than, equal to nums dot length, and nums of mid is not equal to nums of mid plus 1 if um, if mid plus 1 is less than nums dot length and nums of mid is not equal to, yeah. So if nums dot length minus 1 minus mid %2 is equal to 1. So now we are checking on the half, on the, right of, the mid, and we are checking it from the end of that mid position, and we are checking whether that number of elements in that part is odd. So if it is odd, there is a chance that the single element is in that point. If it is even, then it is not there. So if this is odd, then low should be equal to mid plus 1, else high should be mid minus 2. Why 2? Because there could be two elements, same same. Okay, so like, um, in this case, so here the right side is having odd number of elements, but suppose here it is not, odd, it is even, then, and we are at this position, mid is, the second 7, then we need to come in the else part. If it is not, 3, it is something even number like 4, 6, 2, any even number. It's not, apart from 3, as is now the case. If it is any even number, then we need to come to this part, and to come to this part from here, we need to define, subtract -2, and that's what we have done. Wherever we are going to the other part, we are doing either -2 or +2. So to go to the other part, if this is not, getting the things, then what we are doing, since we have low is less than high, and our loop will be terminating when low becomes equal to high. So at that point, we are returning nums of low. Why that nums of low? Because it's already converged to that point, and this single element is guaranteed to exist in this array. That's why we are sure that this element is going to be at this last, the last value of low and high are going to be this element. So I can show you this. Just run this. Perfect. So it's working fine, it's accepting. Now I'll submit this. It's accepting. The other thing that I wanted to show you, instead of returning low, we could have returned high also. Even then this will run. Perfect. Perfect. So, why low and high both are, working fine here? Because low is less than high. As soon as low becomes equal to high, so when low is equal to high, it doesn't matter whether we are turning low or high. We could, we could have done with any of them. So this is the way this problem is, can be solved, and solution can be achieved in a very elegant way. So if you like it, just press like button. And if you have any doubt, please ask the doubts in the comment. I'll definitely try to help you out. Thanks a lot.